What's up, YouTube land? If this is your first time, welcome. If this is more than your first time, welcome back. Here we are in the gorgeous mountains of Colorado, back on the Nook job site. If you don't know what the Nook is, we have a whole playlist dedicated to our 3-container build. It's a shipping container home in the mountains of Colorado. Check out that playlist. Actually, it's probably on this side. Check it out. If you haven't, there's everything you need to know about building a shipping container home. Well, at least the way we did it, and everything that we've done so far to this point. I have yet to discuss our well. Our well that we've just recently built, which is our wellhead's right behind me here, or installed, drilled, is how we're gonna get our water. We have a septic system, it's a mounted system, which is about 208 feet that direction from me up the hill. And then we have our wellhead right here. Now, that being said, we're gonna discuss the entire well system, what type of well system we're putting in and why. And we're gonna go through all the details from drilling the well all the way up to what's going on inside the container house that we've built and everything in between. So thanks for joining me, and let's get started with this. Okay. As I said at the beginning of this video, right behind me here is our wellhead. Our well got drilled to 240 feet before we hit water. In this area, that's actually pretty shallow. We lucked out, thank goodness, because truly, the well driller is gonna charge you a flat fee for a certain amount of footage. In this case, it was 100 feet. It was a fixed fee. After that, they're gonna charge you a rate per foot to drill until they hit water. So the shallower your well is, the better. We also have a great flow rate. Boy, that's a tongue twister. With our well as well. See what I did there? And that's at 15. It's our flow rate, okay? So I'm gonna discuss the office version of me is gonna kind of walk you guys through some of what I'm saying here on site. And that'll explain what I'm talking about as far as flow rates, depth, and all that fun stuff.
Okay, let's interrupt on-site Shane for a second and let Office Shane take over as we discuss the well guts, the well system itself, starting with how do you get a well drilled? All right, so a big rig comes out, a giant truck comes out, and it's going to have a giant tower on it that's going to drill down through all of the overburden and everything else until it gets to bedrock. Bedrock is the ultimate goal because that's where the water is hanging out. What is overburden? Real quickly, overburden is basically anything, dirt, clay, rock, and material, anything that sits above the bedrock that is supporting the water way, way down. In our case, it was only 240 feet. Thank goodness. But that got drilled, and then you end up with a flow rate, which is basically the amount of water that is running through that area that we've drilled. And the higher the flow rate, the better off you're going to be, up to a certain number, of course. In our case, it was 15 gallons per minute. That's really good. We actually don't want it much faster than that because then we'll have to add extra components to the well system itself, and we don't want to do that. So as that drill is going down about every 20 feet, there's drill rods that are added until it'll hit that bedrock. So somewhere within the bedrock is where, like I said, most of that groundwater is reached. Throughout the process, you're going to see water and cutting discharge emerge, lots of crap flying up from the hole. The water that's actually being poured directly into the hole is basically to keep that drill rod lubricated and cooled as it drills through all that stuff to get to the bedrock where we can find water.
Our well has to be a certain distance from our septic system. In this case, we had to have a minimum of 200 feet between our septic distribution area and our wellhead, and that's for contamination reasons. So this is the reason why we picked this spot. We didn't want to be too far from the house because the further from the house we are, the more we got to trench. And if you guys will see, and if you have already seen some of the other videos, this 3-acre property has more rock than I have ever encountered in any build I've ever done. And everyone that's worked with us on this build has said the same thing. The amount of rock on this property is absolutely crazy. That is going to lead me into what I'm going to discuss on why we're doing this type of system, okay? The system that we're doing didn't allow us, because of the rock, to get to our 8 to 9 foot depth in our trench for our water line. Okay, so that's step number one. We have to have a certain depth for our water lines in this type of climate because it snows here. And if you guys think about water and cold, you know, what happens when in between rain and snow? There's a creature behind me. I think he's listening in on this. Maybe he's learning about the wells. When it gets cold enough, at a certain temperature, 32 degrees or below, the water freezes. So rain turns to snow. Water in the ground or above the ground is going to freeze, and we don't want that, obviously. If we're having water run to our house, especially in the wintertime, if it freezes, we got all kinds of problems. People, I'm sure, have experienced broken water lines in their homes for various reasons. This is what we're trying to avoid for underground line running from the wellhead to the house. Okay, so that being said, we weren't able to get to 8 or 9 feet here. It's just not going to happen without literally blasting everything open again. We don't have to do that either. We are going to run 1-inch PEX water line from the wellhead to the house. The reason I'm going from 1 inch from 3/4 is because I can then get a heat line inside the water line itself because of our depth at we're 4-ish feet here most of the way in the trench. Some places a little bit deeper, but for the most part it's only 4 feet. And that heat line's gonna keep our water from freezing no matter what the depth. In theory, I could put this water line above ground with the heat line in it and it wouldn't freeze. Obviously, I don't want to do that for a lot of reasons, but that is how we're going to deal with the shallower depth of our water line trench. Okay, the other issue that we're running into, and because of the depth as well, is we actually are uphill from the wellhead to the house. So from the wellhead to the house is actually running downstream. It's not actually a good thing for well systems because of that flowback issue. So what we're going to end up doing is run what we call a drain back system. And with that system, it's going to basically kind of cover us on the other end when we're having water running into the house and it's cold, and it's going to protect us here at the wellhead at our pitless adapter and all the way at the house as well. See how many times I told you I'm going to use well a lot. Well. Okay, sorry. I have the humor of a 12-year-old boy sometimes. That's going to keep us from having any other pressure issues once it reaches the house. Again, we're going to talk about the well system inside the house and what that involves. But that means I'm not going to have a bladder inside the pressure tank in the crawl space. I'm going to have a bladderless or a hydro-pneumatic tank, meaning there's no bladder inside this pressure tank that we're installing inside the house. You're going to get to see all that as well. Okay, so let's go ahead and go back to Office Shane. Let's talk about the system, how it looks before we actually see it on site, and continue from there.
All right, once we have hit water, we're going to go ahead and install, I'm not doing it. They're going to install the well casing, which is what you see here. Well casing is a 6-inch wide pipe that extends down through all of that overburden and several feet into the bedrock. So this casing is also installed in 20-foot increments, just like those drill rods are done to hit the water initially. That casing serves, the purpose of the casing really is the overall efficacy of your well. And I really always have a hard time saying that word, even though I like to use it a lot. I don't know why. So it's put in place basically to keep the overburden, all that stuff above the bedrock, from seeping into your well and contaminating that water. We want clean, or as clean as possible water running from our well to our house. Once that casing is installed, it's going to extend a few feet out of the ground, which is that green stubbed up thing that you saw behind me on site. And that, again, is to ensure that surface water and debris are not also entering from the ground and down into the well itself. Once that casing is installed, the last component is basically applying that surface seal around the casing. That first 18-ish feet of the casing is over-drilled with a 10-inch borehole, and that's because the casing is a few inches narrower than the well hole itself. It has a bentonite surface seal that's poured into that 18 feet of the hole surrounding the casing. Put water in it, the sealant expands, and it seals the casing from the surrounding overburden, basically almost like concrete. It just seals that whole thing in. Again, we're trying to make sure that nothing is going to leach down into our well from the surface, as well as, I did it again, deeper into the ground, in our case 240 feet. Once that is all done, we come back and we set our submersible pump and our 10-2 wire that I was explaining before. That's submersible 10-2 NM cable and our submersible pump, which is going to go down, and that's what's the purpose of the pump, obviously, is to pull the water from way down here up into the area where we can attach our water line. The next piece that's installed is a pitless adapter, which is basically the piece that's going to take the water from the pump up to where we can connect our water line and our heat line and the 10-2 wiring itself. And I explained we're going to go from 10-2 to 10-3 here, running back to the house because we want to have an extra conductor. I'll show you that in a minute back on site.
Okay, so 115 feet later, we're here at the house. This is where our gas line is connected and running in. This is also where our water line is going to come in. We've got a little bit of a cantilever here. We actually came in with the gas line stubbed out through the underside of this, which is going to be right at grade. I'm debating whether to bring the water line in through our stem wall or if we're going to go ahead and take this in the same direction as our gas line is as well. It's not ideal to go this way, but means we don't have to come back through and drill through the stem wall. Either way is not a big deal. I do also have a stub out when we were doing the foundation that has a feeder of PVC from the inside of the crawl space out to about this location right here. But as you can see, with all the extra excavation for the trench and some extra blasting, it's below me there somewhere. Do I want to dig all that out or not? I don't know. I can't get the Mini X over here to reach down far enough. It's a little bit awkward, especially now that we have our gas line in here. So one of those three options is going to happen. You can also see behind me and in front of me that we've got tracer tape in here, which we dropped in for our underground electrical. And I also ran it for our 2 trenches for our gas line and water line. That's what I was holding in my hand at the beginning of this video, if you guys are paying attention. And what that does is actually allows someone to locate these lines under the ground if there was to be more work done at some point in the future. Whatever happens with the future buyer on this project, it's a spec build, they then can be able to locate not only the underground electrical, which is required, but also our propane gas line and our water line. You don't really want to hit those. Those are always a bummer to hit if you're doing extra work, digging, whatever it is. And that's also why it's recommended that you call before you dig. I know you guys have seen a lot of that. So you want to make sure that that is done because the utility company that comes out can find all those lines and mark them for you because this tracer tape is in here. Once all that's in, once we have our water line in, once we have everything kind of hooked up with our 10-3 that we're running from the wellhead all the way to the house, then we'll go ahead and backfill all that. Tracer tape is in the ground. Speaking of 10-3, I know some of you are out there, you have some knowledge of pumps or you're questioning why I'm running 10-3 from the wellhead to the house. The pump itself is a 3/4 horsepower pump, and it's actually a 10-2 submersible wire that's attached to that. That 10-2 allows us to run, if you guys aren't unfamiliar with that, that's running to a 30 amp breaker at the panel. That's what that 10 gauge wire is for, okay? So that 10-2 represents a neutral, a hot, and a ground within that system. The reason why we're gonna run 10-3 from the wellhead to the house is because it's always nice to have one extra conductor if it's underground, just in case something happens. Again, we're running underground UF feeder wire, but it's gonna be 10-3 because just in case something happens between the wellhead and the system inside the crawl space, we have an extra conductor that we can go ahead and hook up if we need to or switch out if we need to on the off chance something happens underground. Maybe the trolls get to it, maybe the tremors come back and anyway, you know, you guys have seen that, right? With the worms, forget it. Anyway, that's why we're running 10-3 from the wellhead to the house. 10-2 is on the submersible pump. And again, that pump is going 240 feet to our water.
So this pitless adapter is going to be set at the depth of our trench. That's where the water line is running in. In our case, it's 4 feet. Frost line for footings and structure in this area is 4 feet, meaning we have to be 4 feet below the frost level to make sure that we don't have any heaving for our foundation. Now, that doesn't apply to water lines. As we've explained, this is exactly why we're doing the heat line and we're also doing the bleed back system that I'll explain here in a second. The pitless adapter is going to be at that 4-foot trench level. If we were at the true level we needed to be without all that rock, if we could dig deeper, it was going to be at 8 to 9 feet. So this pitless adapter is going to be dropped in at 4 feet. I can hook up the water line here, and I can run our power from the pump all the way back to the house as well, because we're going to have a control box that needs to be tied to. So that 10-3 wire is going to run from here along with our 1-inch PEX into the house. Our wiring is going to run up to a control box. We're going to have a disconnect switch for the pump. And then we're going to have a pressure tank. We're going to have a pressure release valve. And we're going to have a pressure gauge attached here with a switch. All of these things control the pressure tank itself. A normal pressure tank is going to have a bladder inside of it, but with a bleed back system, we're going to have a hydropneumatic pressure tank, meaning it's not going to have a bladder in it. Okay, so let's just talk about the pressure tank and how that actually works. So pressure tanks rely on compressed air and the pump system to work properly. So once that valve is open and the compressed air is applied, it applies pressure on the water inside the house, that is what forces the water to flow through the pipes of the home. So that's all the water lines. So it's like, hey, I'm turning on the faucet, that valve is going to turn on, it's going to push water through that supply line up to the faucet that I'm turning on. Once that water in the tank falls below a certain level, like I was saying, that pump starts up and allows more water inside the pressure tank itself. So this pressure tank fills up with water from the pump, and when it's full, the pump shunts off. When it gets below a certain level, that gauge is going to say, hey, we're below a certain level. That pressure switch is going to kick on and say, hey, pump, bring me more water back until we fill it up. And these are all cutoff levels that are set in this pressure tank. So the difference between bladder and bladderless tanks or hydropneumatic tanks is that the compressed air that's inside that bladderless tank is in direct contact with the water. It's really important in this system because that compressed air now has to take on two roles within that tank. The compressed air can be used to push on the water, and it also absorbs extra pressure and regulates the tank. Okay, so that's step one in running a bleed back type of system. Step two is protecting that water running back to the well itself to keep it from freezing. This is why we're doing it. And again, because we're going uphill, it needs mechanical assistance to get back to the well once it's not being used in the water line between the house and the well itself. So that bleed back system actually enables the water to bleed back from the well tank down into the well at whatever level that is and feed down that drop pipe into the pitless adapter when that well pump shuts off. So that system will also purge air when the well pump is in use. So if the bleed back system wasn't installed on our particular house, the water would be held in the pipe longer and it could potentially freeze. Again, that's why we're putting the heat line in the PEX supply line from the well itself. And I'm also upgrading that size from 3/4 to 1 inch so we can actually fit the heat line inside that PEX itself. Okay, there you have it. That's the inner workings of the well system. Let's go back to on-site Shane.
Well, that's it. Oh, man, I couldn't help myself. I had to do it one more time. That's it for this one, guys. Hopefully, YouTube land, you learned something from this video. If you have any other questions, drop them in the comments below. I'm gonna link everything that I've used on this well system below as well. Gosh, I can't help myself. Everything should be there. Hopefully you guys enjoyed this video. If you did, give me a big thumbs up. I really appreciate that. Well, I did it one more time for you. As always, guys, keep learning, keep progressing, and keep building. Oh, crap. My ladder just blew down. Oh, this is going to be an adventure getting down now. Son of a...